Hello friends, in this lecture we are going to start ring theory, and the first topic is the definition of ring. So ring, what is a ring? A non-empty set, a non-empty set R is said to be ring with respect to two operations. So these are the two operations that were denoted near called addition and multiplication. If it satisfies following axioms. So first of all, addition is clause. Addition in clause means if we take two elements A and B belonging to R, then A plus B is belonging to that is all A plus B is belonging to R. Second property is addition is associative. The second property is addition is associative, means if we have A, B and C, three elements belonging to R, then A plus B plus C must be equal to A plus B plus C for all A, B, C belonging to R. So this is a third property is existence of identity, means if there is an element, there exists an element which is denoted by 0 such that this condition is satisfied, means A plus 0, or you can add 0 plus A, then we will get A for all A belonging to R, then this element is called identity or 0 element in R. Similarly, for fourth property for ring is existence of additive universe. So in this property we have for each element A, for each element A belonging to R, there exists an element B belonging to R such that A plus B is equal to B plus A. What we will get? We will get identity of the element which is denoted by 0. So this the element B is called additive universal. That means for each element we have their element B, on adding A we get the additive identity of the ring. So the fourth property is additive is commutative. Commutative, what it means? It means A plus B is equal to B plus A for all A, B belonging to R. That means if we add two elements A plus B, or we add B plus A, then these are equal. So addition is commutative. And the sixth operation, which is the sixth property is multiplication is cross. That is A comma B belonging to R. We have A dot B belonging to R. यानी कि for any two elements A, B belonging to R, we have A dot B belonging to R. That means these are closed under multiplication. So the seventh property is multiplication is associative. So what is for all A, B, C belonging to R, A dot B dot C is equal to A dot B dot C. So this property is associativity or multiplication, and the eighth property is multiplication distributive over addition. A dot B plus C is equal to A dot B plus A dot C. This is called our left distributive. And in case of right distributive, A plus B dot C is equal to A dot C plus B dot C. So this is the right. So overall there are 8 properties. If for a non-empty set these all properties are satisfied, we say that this set is a ring. So we write R with the two operations, namely addition and multiplication, is a ring. So next we will study about some types of ring like commutative ring. So in commutative ring, if we have, as we see that in case of ring, multiplication is closed and multiplication is associative. So if a ring satisfies commutativity for multiplication, we say that this ring is commutative. So a ring in which A dot B is equal to B dot A, or all A, B belonging to R is called a commutative ring. So for multiplication operation it must be commutative, then we say that it is commutative ring. Now next type of ring is ring with unity. So in ring unity, ring R is said to be ring with unity if it contains multiplicative identity, that is, there exists an element denoted by 1 belonging to R such that A dot 1 is equal to A 1 dot A for all and belonging to R. So this type of ring is with unity. Now let us consider some examples for clarifying these definitions. So if we take set of integers z and we have two operations on it, addition. First operation is addition and second one is multiplication. So is it then so let us check that what properties this set satisfies. Integers, that means if z1 and z2 are two elements belonging to z, and when we add two integers, then the required is also integer, then it belonging to z. So first property, that it is closed under the addition. Second property, addition is associative, that means z1 plus z2 and z3 and z1 plus z2 plus z3. So yes, for all z1, z2 and z3, yes. Addition is associative also in this case. The third property is existence of additive identity. So yes, there is additive identity 0 which belonging to z such that A plus 0 is equal to A is equal to 0 plus A for all A belonging to z. Which is now what is existence? What is inverse for any integer? Existence of inverse. So if we take any element, say z1 belonging to z, then what is its inverse? So z1 plus minus of z1, and we get the additive identity 0. So this one is the inverse for the element z1. So for any element, if you take from this z, there is also a inverse of this element. So this existence of inverse. And the fifth property is addition is commutative. Yes, it's commutative. Yes. So for any element, z1 plus z2 is equal to z2 plus z1. Now the sixth property is multiplication is closed. Yes, if we take any integers z1 and z2 belonging to z, then z1 dot z2 is belonging to z. And the seventh property is multiplication is associative. Yes, you can check that if you take any integers z1 dot z2 and z3, z1 z2 z3 is associative. So the eighth property is distributed over addition. So a for a, b and c belonging to z, what a dot b plus c is equal to a dot b plus a dot c. From this we can see that this structure is on which the two operation plus and addition and multiplication is defined is rings. So yes, this is 3. Now as we previous also defined the commutative ring. So is it commutative ring? Commutative ring. So yes, is it this is commutative ring because the operation multiplication defined on this structure, and you know that if we take 3 commutative, if we take 3 integers z1, z2 and z3 belonging to z, and z1, z2, z3 is equal to z1, z2, z3, a multiplication operation is commutative. So this structure is commutative ring. Is this ring is with unity? Ring is this ring is ring with unity? Yes, we have a element namely 1. If we multiply it with any integer, then we get the same integer. So ring with unity. So if we take any element a belonging to z, then for all a dot 1 is equal to 1 dot a is equal to a. So we have an element which is 1, on which we multiplying any element or an integer with it, we have the same element for all a belonging to R. So this is the ring with unity.